Good morning, students. Our next topic is lithium-ion batteries. It's abbreviated as LIB, and it's another type of rechargeable battery. And normally we are using these batteries in portable electronic devices and electric vehicles and military purpose and aerospace applications. The simple mechanism behind this lithium-ion battery is movement of lithium ions from anode to cathode and cathode to anodes. Only the mobility of ions determines the charging and discharging reaction. Keep in mind, when the lithium ions is moving from the negative electrode to the electrode to the positive electrode, discharging reaction takes place, and vice versa during the charging reactions. Let us get into the detailed mechanism regarding the lithium-ion batteries. And the major components in the lithium-ion batteries is anode, cathode, and the electrolyte. It's a lithium polymeric electrolytes. And the anode, what we are using here is a graphite, that is nothing but simple carbon. And the cathode, what we are using is lithium metal oxides, of more specific lithium cobalt oxides. As I said earlier, when the lithium ion moves from the anode compartment to the cathode compartment, that is discharging reaction, whereas when it moves from the cathode compartment to the anode compartment, that is charging reaction. During this process, it gets entrapped in between the planes of the graphite unit, and in the similar case, in the cathode compartment, it gets entrapped in between the lithium metal oxides cavities. I actually represent in the pictorial representation and this given slide. Here, the movement of lithium ions from the graphite compartment to the metal oxide compartment is shown in a green line, and the movement of lithium ions from the lithium cobalt oxide cathode to the anode, that is graphite, is shown in the red lines. And the electrochemical reaction behind this lithium-ion batteries is mentioned here. In the cathode, the lithium cobalt oxide can get converted to lithium ions with the release of electrons, whereas in the anode, the carbon is nothing but an allotropes of, it's a graphite type of allotropes plus lithium ion combined together along with the electron give rise to lithium carbides. Overall, the reaction is represented as lithium metal oxides plus carbon n times. Since a layer of graphite is there, that's why we are representing as n times, and we are getting the lithium carbides plus lithium cobalt oxides. Always the forward reaction is charging reaction and the backward reaction is discharging reaction. And it's a detailed mechanism regarding the charging and discharging. And the overall potential developed in this system is almost 4 volt. It is more than the nickel cadmium battery and the simple Leclanche cell. Now let us discuss about the advantages of lithium ion batteries. They have a high energy density than other rechargeable batteries, and they are less weight when compared with the other rechargeable, and they produce high volt, about 4 volt as compared to the other batteries. They have improved safety and more resistance to overcharge. No liquid electrolyte means they are immune from leaking. Fast charge and discharge rate. The major disadvantages behind these lithium-ion batteries are they are quite expensive and they are not available in standard cell types. Next, we are going to discuss about hydrogen-oxygen fuel cell. Normally, this type of fuel cell is used in Apollo spaceship, and the byproduct developed in the fuel cell is nothing but water, and that water they are utilizing for the drinking purpose since it's more ultra pure. And here the anode compartment is nothing but hydrogen and the cathode compartment is oxygen, often oxidizing agent, and that produces the electricity, and the byproduct is water, and the electrolyte what we are using here is potassium hydroxide. And this is the block diagram regarding the hydrogen oxygen fuel cell. and the anode what we are using is hydrogen is get into the system, and here the oxygen from the cathode compartment is getting into the system, and these two oxygen gases get separated by a carbon rods, and the two carbon rods get separated by an electrolyte. Here the electrolyte what we are using is potassium hydroxides. Now let us discuss about the reactions involved in this hydrogen oxygen fuel cell. As I said earlier, always anode reaction is oxidation and cathode reaction is reduction. When the hydrogen is oxidized, it will oxidize to H plus ion with the release of 4 electrons. The 4 electrons get involved in the reduction for the oxygen and it get converted to water molecules, and the net reaction is generation of water molecules. Here I have given some pictorial representation regarding how this generates electricity. So from the anode, hydrogen is passed over to the system, and once it reaches a carbon electrode, it gets oxidized with the release of electron, and this electron move towards the cathode compartment, and there we are releasing the oxygen. It get reduced by the electron released in the anode compartment, and it generates water molecules. And the more important thing is, in both the carbon rods some cavities is there, and it is getting filled with platinum or palladium nanomaterials. The reason behind this, or to flip up the rate of anodic reaction and cathodic reaction, both the carbon rods are incorporated with platinum or palladium. So this will flip up the rate of overall anodic and cathodic reaction and generates electricity, and the product is nothing but water in the system, and it's ultra pure. Now let us discuss about the advantages of fuel cells. And it is a high energy conversion efficiency. Modular design, different size of available depends upon the requirements, and it's very eco-friendly, low chemical pollution, fuel flexibility, cogeneration capability by using heat produced, quiet operation, unlimited runtime while fuel is supplied, no need to be recharged. The major advantage of the fuel is this specific point, and low maintenance due to lack of moving parts, low running cost, lower weight and volume than conventional battery for electrical power vehicles, and it's having a potential to power portable device for longer times than the conventional batteries. Now let us discuss about the disadvantages of fuel cells. It includes the manufacturing process and materials are expensive, and the complicated infrastructure is required for pumping gases. Since we are dealing with hydrogen gas, proper safety measure has to be taken into consideration. Fuel must be reliable and continually supplied. Distribution, storage and transportation of hydrogen is still difficult. The technology of producing hydrogen from other fuels is still being developed. Few refueling stations are available for fuel cell vehicles. There are still some technological issues to solve with regard to water regulation and temperature control in some fuel cells. Electrodes are expensive because they must be function as a catalyst. And the reason behind this catalytic property is, and the efficiency of the fuel cell lies in the nature of metals incorporated in the carbon rods. That plays a major role in the fuel cells. And let us come to the quiz questions. So far we discussed about the rechargeable batteries like nickel cadmium lead acid batteries and fuel cells. Just have all the concepts in mind and try to answer all the quiz questions. Question number 1. Dry cells are in reality a form of which cell? The answer is it's a Leclanche cell. What is the voltage rating of lead acid battery? 2.2 volt. As the cell starts discharging, internal resistance of cell will increase. Overcharging of lead acid cell can cause formation of which of the gas? Since we are dealing with hydrogen and oxygen, due to overcharging, the production of hydrogen is more, so the answer is hydrogen. Primary cell is one of the category in the batteries, whether which comes under reversible or irreversible. True or false? It's irreversible. The answer is true. The stage of charge of lead acid battery can be determined by what type of instrument? Hydrometer. How do you express the capacity of battery? Ammeter per hour. Why nickel cadmium batteries are preferred more than lead acid battery in military applications? The reasons are: it can be easily charged and discharged. The discharge rate is higher than the charging and delivers large amount of power. Dear students, here I provided few assignment questions, and these are the most important questions for the examination point of view. Please complete the assignments to the earliest and make it sure whether you have highlighted all the key points. While writing the assignments, please thorough with the concepts and deliver to the earliest. Thank you.